Okay, let's have a look here. We've got Z and its conjugate. Show on the Argand diagram the following. Okay, so I'll just rewrite that as Z minus 1 plus 4i. That's equal to Z minus 5 plus 0i. So on the Argand diagram, we have 1 plus 4i, and then minus 5 here, and the distance from Z to this point and Z to this point should be equal. So that means it has to be this line here that's perpendicular to the line joining them and passing through the midpoint. Because everywhere on this point, this line here, everywhere on it, for example, there's Z, the distance from Z to there and the distance from Z to there will be equal. So that's the K. Now we have this transformation. So this transformation is interesting because it's like the year I just saw a moment ago, I think 83, where it looks like this is probably going to be the real part and the imaginary part. So this transformation, let's have a look at it. That's a half. That will be 2x. And then this is I over 2. And then x minus x. And then you have yi, 2yi, is it? I think so, isn't it? Because it's x plus iy minus x minus iy. So the x's cancel, and yeah, it's 2 iy. Well, the 2's cancel, so that's equal to x minus y, because I squared is minus 1, plus 0i. So what the transformation does is it subtracts the x and the y, and you have 0. So like it's going to be a line. I'm going to need to have 2 points on the line. Let's see. So this point here for sure, which is the midpoint, let's call that P. So P is the midpoint. So 1 minus 5 is minus 4, so that's minus 2, and then 2i. Yeah, okay, that's P. Now I should find another point on it. Oh yeah, and let's transform it. So the new P would be at x minus y. So minus 2 is minus 4 plus 0i. All right. What's the slope here? So that's 6 units. And that's 4 units. So that's a slope of 2 over 3. So the perpendicular is minus 3 over 2. So that means you come out here 2 units and you go down 3 units. If that's 2 units, that's down 3 units. So if I take a Q here, okay, if I go to the right 2 units, so that would be having me at 0 plus 2i, but then I have to drop 3 units, so that's 0 minus I. So I think a second point would be 0 minus I. So that means transforming that, I get 2 plus 0i. So it looks like I'm going to end up with the horizontal axis again. Put it in green. Cross here. That's the image. Because the imaginary part has disappeared, so the line just gets moved down to the x-axis. Yeah. Seems a bit funny, doesn't it? Okay. Again, I wasn't confident about that, and I wasn't confident about 1983. It just seems a bit weird that the transformation just becomes the x-axis. Well, if you spot something I've done wrong, let me know. I mean, maybe I think the K is a line that's equidistant from these 2 points. Yep, okay. Don't know. Using real numbers, find the 2 quadratic factors of x4 plus 1 and hence otherwise write down the complex roots of it. So in other words, solve x4 plus 1. Okay. Now, why does it say using real numbers? Find the 2 quadratic factors of x4 plus 1. And they give us a hint. So they don't want us to use imaginary numbers just yet, even though I can see. Well, anyways, okay. So we'll take their suggestion. We'll say x4 plus 1, that's got to equal x squared plus px plus 1 times x squared plus qx plus 1. Now we can try and figure out the p and the q. So do I have to multiply it out? I think I do. Okay, so that equals x4 plus qx cubed plus x squared plus px cubed plus pq x squared plus px plus x squared plus qx plus 1. So that's equal to x power 4 plus q plus p x cubed plus 1 pq and 1. So 2 plus pq x squared, and then the x is px qx plus let me squeeze it in, I don't want to go to a new line again. Okay, equals x power 4 plus p plus q x cubed plus 1 pq. Okay, so 2 plus p plus q x squared, and then the x is q and p plus q x plus 1. So these 3 must be 0. So p must equal minus q, and 2 plus p plus q, that must equal 0. That's wrong. So I've done something wrong in my multiplication if I got such an equation. Let's backtrack and find the multiplication error. Okay. X squared times x squared x4. That's qx cubed plus x squared. Okay, and then multiply by px. Px cubed plus pqx squared plus px, and then multiply by 1, which is x squared qx and 1. Alright, that looks okay. x4, that's alright. Qx cubed, px cubed, no other x cubed, so that's right. X squared, pqx squared, I think that's what I missed. So x squared plus pq x squared. Okay. Plus pqx squared and the x squared there. Okay, and then qx, px, qx and px. Okay, that's okay. And then 1. Right, so we still have the same. P must equal minus q. And then 1 minus p squared must equal 0. So, a little or just p times q equals minus 1. Oh, so actually it doesn't matter which one we choose as positive and negative because of symmetry here. So we can just go with p equals 1 and q equals minus 1. But of course the other way around is perfectly valid. And again, we can swap these factors, so it doesn't matter. So okay, so I have the p and the q. So that's good. So now back here. So that's x squared plus x plus 1. And then x squared minus x plus 1. Now, equals 0. Now, can we factorize here? I don't think so. So, quadratic formula. X equals minus b plus or minus the square root of b squared, which is 1, minus 4ac, all over 2a. And then here, minus b plus or minus the square root of b squared, which is 1, minus 4ac. Okay, so it looks like, I've just remove this here, we have our 4 answers. So it's going to be minus 1 plus I root 3 over 2, minus 1 minus I root 3 over 2, 1 plus I root 3 over 2, and 1 minus I root 3 over 2. They're the 4 roots. And yes, they're all complex. And if you power 4 any of them, you should get minus 1. I wonder if I can check that on the calculator here. Let's have a quick peek. Just to confirm these, since it was a little bit of a tricky question. Hang on, how do I do this again? Okay. Power 4 minus 1 plus root 3 oh. That didn't quite work. Perhaps I made a mistake. Yeah, no, that's right. And that's right. Okay, and then I check the other one. That's right. That's right. Okay. Let me type that in again. -1 plus I square root 3 over 2. My calculator is refusing to calculate that for me. No, it's not working. It's not working, so I can't check if it's right. So I wonder if I can check on a different website. 1 second. So what I am able to get is the 4 roots plotted here. So that one there, where is it? -1 plus root 3. So that's that one there. That's the first one. And then -1 minus root 3 over 2. That must be that one there. And then 1, yeah, that's that one there. And then the last one, it must be that one there. So I think it's okay.